object A is going towards south to north and B is going west to east. Determine the relative velocity of A with respect to B. So here we need to have directions like in atlas. Let us mark the directions. This is north and this is east. That means this is west and this is south. So object A is going from south to north. So let me represent velocity of A. Let us assume velocity of A is VA and that is going from south to north, that is upwards on this plane. Then this B is going west to east, so B is going west to east. So it can be anything like this. So B is going west to east this way. So this is VA, velocity of A, and this is velocity of B. So we are supposed to find velocity of A with respect to B. So velocity of A with respect to B is velocity of A minus velocity of B. That's how it should be done. But velocity of A minus B is velocity of A plus of minus velocity of B. That means subtraction is nothing but reverse the direction of one of the vectors and add it. So addition means bring the tail of one vector over to the head of the other vector and draw the line from the tail of one vector to the head of the last vector. That is the procedure, we know that. So here VA plus of minus VB, so let us reverse the direction of VB here. So once if you reverse the direction, this is minus VB without changing the magnitude. Then when you add, place the tail of VB onto the head of VA. So now the VB was here in this direction, so VB was here in this direction. This is VB in the opposite direction, so it is minus VB. So then now the resultant vector is actually the tail of this vector to the head of this vector. This is a resultant vector. This is, now if this is VA, this is minus VB, this stands for VA vector plus of minus VB vector, which is nothing but velocity of A with respect to B. So this vector is, we know that this is north and this is east and this is west. This vector is in between north and west, hence this vector is northwest. So relative velocity of A with respect to B, relative velocity of A with respect to B is VA minus VB. Along which direction? Relative velocity direction is northwest. So this direction is northwest. So the other approach to this is, let us give some values to it. So suppose velocity of A is 10 meter per second along the northern direction, so south to north direction. So here let us see, this is I cap, this is J cap, then this is going to be minus I cap, this is going to be minus J cap. So in such case, if velocity of A towards north means J cap, so this we can refer to as velocity of A vector is 10 J cap. Then velocity of B was originally going towards east, let us call it say 20, and towards it is eastern direction 10 in same meter per second unit, so 20 meter per second along eastern direction means this can be referred to by the vector along eastern direction means velocity of B vector is 20 I cap. So what is velocity of A with respect to B, which is VA minus VB, that means 10 J cap minus 20 I cap. So here what you have got is J cap and minus I cap. You know that I cap is east, minus I cap is west. J cap appears as it is, J cap is north. So this refers to northern direction. This minus I cap refers to western direction. So the answer is velocity of A vector with respect, velocity of A with respect to B is this value in the northwest direction. The value of this is, we know that whenever there is a vector, so velocity of A with respect to B, when you want to take the modulus, it is root over 10 square plus of minus 20 whole square, root over 10 square is 100 plus 20 square is 400, so you can take 100 out, so it is root over 500, so or 10 root 5. So the values of the relative velocity is 10 root 5 in the northwest direction. This way also you can find the relative velocity either using vectors or using this triangular law of vectors.